Numbers, data, and countless features. It can feel like you're drowning in complexity, right? That's where dimensionality reduction comes in. This incredible technique takes overwhelming datasets and transforms them into something clear, manageable, and insightful. Welcome to day 21 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we're diving into the fascinating world of dimensionality reduction. You'll learn what it is, why it's essential for simplifying datasets, and how it helps uncover hidden patterns. Whether you're tackling messy features or just curious about smarter data strategies, stick around. By the end, you'll have a clear roadmap to mastering this game-changing concept. Dimensionality reduction is like cleaning up a cluttered room. Imagine having a dataset with hundreds or even thousands of features. It can be overwhelming, not just for us, but for machine learning models too. The goal of dimensionality reduction is to simplify these datasets by reducing the number of features while preserving the most important information. It's about finding the right balance between simplicity and accuracy. Why is dimensionality reduction essential? There are two main reasons why dimensionality reduction is a game changer: efficiency and visualization. Efficiency. Fewer features mean faster computations and easier modeling. Machine learning algorithms run smoother, and training time decreases significantly. 2. Visualization. High-dimensional data is impossible to visualize. Reducing dimensions to 2D or 3D allows us to create meaningful visual representations, helping us understand patterns and relationships in the data. How does dimensionality reduction work? There are two primary methods for dimensionality reduction. 1. Feature selection. This involves selecting the most important features from your dataset and discarding the rest. Techniques like correlation analysis, variance thresholding, or using algorithms such as random forest can help identify key features. 2. Feature extraction. Instead of selecting features, this method creates new features by combining existing ones. Principal component analysis, PCA, and t-SNE, t-distributed stochastic neighbor embedding, are popular techniques for this. They transform high-dimensional data into lower-dimensional representations while retaining critical information. Common techniques of dimensionality reduction. Principal component analysis, PCA. This is one of the most widely used methods. PCA works by identifying the directions, or components, where the data varies the most. These components are then used to project the data into a lower dimensional space. t-SNE. This method is excellent for visualization. It focuses on preserving the local structure of the data, making it ideal for creating 2D or 3D plots that reveal clusters or patterns. Autoencoders. These are neural networks designed to learn compressed representations of data. They're especially useful for complex datasets like images or text. When to use dimensionality reduction. When your dataset has a high number of features compared to samples. When you're struggling with overfitting in your machine learning model. When you need to visualize high-dimensional data to uncover hidden patterns or clusters. In conclusion, dimensionality reduction simplifies your data and brings its true potential to light. It makes your models efficient and reveals hidden patterns. Next, we're diving deep into one of the most popular dimensionality reduction techniques, principal component analysis, PCA. Click on the screen to continue to the next video and take the first step in mastering PCA. See you there.